Hi, my name is Luka Mustafa and I'm the CEO of IRNAS, an advanced applied development company based in Slovenia. We are a team of 16 young engineers creating advanced IoT solutions. With full in-house manufacturing capabilities, we bring products to life very quickly and efficiently. With this, we're the experts in wireless optical communications, in advanced applied IoT solutions, where we create products for the smart infrastructure, for tracking, and various other niche applications. As well as we are a certified design partner for Nordic Semiconductor and creating the embedded solutions on that platform. For the past 8 years, we've been perfecting the way how we work with our clients and bring new products to the market. We've often seen they get stuck at being too small of a customer for their subcontractors. We've seen that it's hard to get capacity at low volumes and getting you started. And we've seen there's a lot of communication needed if there's a lot of partners. So our process has changed to be the one-stop partner for our clients, where we take care of everything with our in-house capacity and our network of partners. Now, with this experience, we found various ways how to go about digital transformation. And these are the things we'll be talking about today. Digital transformation for each of our clients is different, but they all have in common that they're solving a real problem in the real environment and want the fastest and most efficient way there. So the transformation happens on the added value level. Now, how to get to that point is a different process for each. But there are 3 common topics on how we can tackle the hardware part of the whole process. Today we'll be looking at the off-the-shelf products, which are products that already exist and can be used straight away for the digital transformation. We'll be looking at the generic design solutions, which are half-built products which we can customize to our specific application and need, and fully custom solutions where we are the experts in creating them from scratch, highly optimized for our clients. To highlight all of these cases, we've prepared a number of examples through which we discuss these ones. First one is about off-the-shelf solutions. So an example of this is an industrial process where we need controlled environmental conditions, controlled motion of people in the space, or some other parameters which are quite commonly understood, and sensors exist for them. So here's a solution we've successfully implemented with our clients from our partner SenseStick. The product's called SenseStick and SensePuck, which are microclimate sensors collecting temperature, pressure, humidity with either battery-powered or batteryless operation. Now, these devices you insert the batteries or just activate, leave them in place, and they will start sending you data through the LoRaWAN network. The benefit of that is if you can define your problem to use an off-the-shelf sensor you can find, put it on the wall, you get data immediately, and you start creating the added value and solving your digital transformation problem right away. So we do recommend that everyone does that in the initial stages of the project with whatever sensors are the closest to what they want to sense. Even later on, you may find you need a customized solution. Start with this because that brings you at least halfway almost immediately. So to sum up off-the-shelf designs, their benefits are fast deployment as soon as you can get them. They're validated, certified designs, which means you can sell them, resell them, or relabel them as you need. And you get valuable data almost immediately. Now, the risk of doing things this way can be the long-term supply of such products, can be the lack of control over the product, either the features and the need for customization, or over the quality and small details of things, as well as you always require some external support to get things going and nicely integrate them in your process. But overall, we always advise you start with this and then move to one of the other 2 options if need be. The second example we show today are the IoT sensors for agriculture and other environmental applications. Now, this topic is specific because all of these applications are rather similar to each other, but yet vastly different one from the other, and they need to be a standalone product in most cases due to mechanical use case or other sensing requirements. But ultimately, these are rather simple devices sending between 1 and 10 different sensor values periodically at lowest power as possible. So over the past Things conferences, we've been talking about these applications and also learned a lot of very interesting points. A good example of a project where we work with Plant E, creating microbial fuel cells in using a generic design, is creating a PhenoCam solution which looks at the plant and reports back the emitted wavelength, so the color of the plant that is actually powering the microbial fuel cell in the ground underneath. Now, this requires a lot of homework. Sensors need to report value, they need to be low power, and like the overall system needs to work. But given that the solution we're demonstrating here is a very novel product which exists in a few 10 units in the initial stage, a lot of development does not make sense and is very risky because it's a large investment in hardware which ultimately doesn't add that much value to the project, because it is not about the hardware, it is about, do we get the power from the ground so the thing can survive indefinitely from it, and do we get the values that report the state of the plant health. Now, the generic design has been a huge aid in this process. So we've been working with the generic node from the Things Industries in implementing exactly the solution. So we've taken the design which works out of the box, added the sensor support, added the custom harvesting electronics to work with the plant cell, and roll out a working product quickly and efficiently in a much better and more efficient way than doing a full custom development. But at the same time, given the specifics, we couldn't just take an off-the-shelf product and plug this all together. To sum up, using a generic design like generic node from the Things Industries is it gives the fastest possible route to development and prototyping any new solution which doesn't exist yet. So you get a whole set of baseline functionality which is there, which is proven and tested, and you only modify small bits and parts that you need for your solution. It's very good for market screening, but also it's good for production applications where you're not focused on hardware. You're really focused on just adding the value, and hardware is the necessary overhead you have in place. Now, the risk of using a generic design is if your solution grows in complexity beyond what the architecture of the system is supporting, then you may have a very hard time adopting things and modifying it to do exactly what you want. There's obviously always the opportunity for full-scale optimization, cost reduction, and general improvement for product development if you do, let's say, 100,000 units or more. And we've seen that with our clients as they grow, going to fully custom design makes perfect sense, but stages in between or before that can be very efficient. Speaking of custom solutions, here's our third example, which highlights customized solutions, for example, for tracking animals and various other tracking applications. You may know us from previous conferences about our solutions working with smart parks and tracking animals from rhinos to elephants and various other projects, even underwater. Today we'll be talking about another client of ours, Telesport, which has the digital bell for the animals. Now the animal wears this, goes out in the wild for the summer, and then in the fall it's retrieved based on the position of this device. Now the need for a custom design here was clear because the solution integrates multiple communication technologies, so NB-IoT, LoRa, and Bluetooth, various very product-specific features in terms of communications, and is extremely power-saving and optimized for this application. So the development of this product went really in-depth for each of the technologies built in place, and because our in-depth knowledge of every single component of the system as we've built it up, we understand exactly how it works and can optimize it further. So the whole point of why go for a custom solution is not only to have the full control, but also through the design process to gain in-depth knowledge of all the components and exactly understanding how they work and why they do what they do. Custom technological solutions, so custom development, has a number of benefits. First is having full control over the intellectual property and all the details of the product itself, which means you go in great detail to fully optimize it and have really the best and most fine-tuned product. And obviously this allows you to do most added value on a piece of hardware which is selected by you and you have full control of. Now the risks of going into the full custom development are essentially significant time, money, and effort investment, as well as doing all the certification and other work. Now, what we see is people sometimes too often jump into the custom development without clearly nailing down the added value and proving their business case. Because investing heavily in the beginning without a solid sales process in place is a lot of effort. That's why we work with our clients that we find the best technical solution and then can focus on the business aspects and creating the added value end to end. With our years of experience, we've fine-tuned the process how to best support our clients. So we've learned that it's very important to deliver often and test things in the field as often as possible. That's why we always try to find a way how to validate ideas and concepts with off-the-shelf and existing products. Taking 10 units or 100 units, putting them out for a few weeks or a few months, seeing how that behaves, what we get from those. If that solves the problem, perfectly. The next step is, however, saying, okay, we need this better, we need to fine-tune this. Then we take the next step into using a generic design or going towards a fully custom solution, where again the same principle applies. Test and deliver often and validate things work correctly. And because of that, we've had also to fine-tune our internal process, buy all of these machines and put everything in place so we can quickly build iterations and new products and not wait for too many external partners and things to happen. So with that, we can summarize the three concepts. You should always go for an off-the-shelf solution first and really have good grounds why you want to go to a generic or a custom design. Once you clearly understand what needs to happen, then if you can get away with using a generic design, that is by far the most efficient process for everyone involved and gets you to the market fastest. But if you're really after detailed, complex solutions which are super fine-tuned to your use case, then fully custom development is needed, and you need very good requirements and ideas what you want to do with that. With that, I would like to thank you for your attention and enjoy the rest of the conference. Hope to see you in Amsterdam as well.